Okay, welcome to 12.2, Other Types of Decision-Making Systems. An expert system is a real-world use of artificial intelligence. It mimics human cognition and communication to analyze a situation or solve a problem. This would be like the MIT Common Sense Computing project. You would see expert systems in very large corporations. The IBM Watson, while I've referred to it as a decision support system, is a type of expert system because when it played the Jeopardy game, it actually had to understand context and natural language processing in order for it to answer the questions properly. So the reality is that these tools do have practical use beyond just the research that's done in universities. So some of the expert system components include a user interface, the interface engine, and a knowledge base. The knowledge base is what's interesting because how the knowledge is represented will ultimately determine what the expert system can do as well as how quickly it can do it. There are various techniques that are used in storing information and keeping that data around. And so what technique is used and how much data they can pump in. I go back to the Watson example. What Watson does, especially in the medical arena, is it takes a large amount of unstructured data. They will actually feed in numerous journal articles that have correlations and other types of statistical analysis based on medical treatments, symptoms, and so forth. Feeds all of that in, and Watson is actually able to discern what is needed at a particular time based on the context of the patient, based on what the patient is telling them. Knowledge representation is how do we represent this information from the expert system? Is it in cases? Do we knowledge from hundreds of thousands of cases to draw inferences on? Is it a neural network that are stored as networks in a node for adaptive learning? Or do we just use some basic rules based on a human's expertise? The cases and neural networks are kind of what Watson actually uses. Because it's using unstructured data, they've developed their own algorithm and algorithms to actually do this effectively. So a neural network, how do you train a neural network? We have a glossary, net salary, own home, job stability, having a family, likes a social life that may point to stay at a current job, leave a current job, and what we can do is we can have strengthen the signal or weaken the signal for either staying at a current job or leaving a job. So for example, staying at a current job, your gross salary, you own a home, and you like a social life. You leave a current job, it's your gross salary is a weakened signal to own home to likes a social life. So this was an example that they used way back in 1989 when they started talking about neural networks. Agent-based modeling is a simulation technology for studying behavior for large numbers of individuals. So what we will do is we'll have these software agents that literally act as collectors of information, and the simulation contains these agents making decisions to understand behavior of markets and other complex systems. So what it does is it basically collects the data and analyzes what people are doing so that you can understand the behavior of individuals from a variety of places. NASDAQ performed a simulation to investigate the effort of a switch in tick size from fixed eighths, 1.25, to decimals. Instead of 1/8, 3/8, they did to 1.25 as a decimal. They found an increase in the buy-ask price spread instead of initially predicted, decreased because of the reduction in market's ability to do price discovery. So by doing this agent-based modeling and putting things out there, they literally found that they would actually increase the buy-ask price spread. The real-time enterprise IT gives companies a way to know how they are doing at the moment. There was a book by Bill Gates called Business at the Speed of Thought, which has permeated in terms of a couple of statements that he put in the book. And what we want to do is IT has allowed us to understand our current environment as quickly as possible. Some systems are more real-time than others, and there's a lot of factors that go into this. The enterprise nervous systems, our infrastructure, those types of applications that are around the operation of the company, they coordinate company operations. Straight-through processing reduces distortion in supply chains. Again, you can visualize these a lot easier. The enterprise nervous system are these nodes and lines that go around the organization. Straight-through processing goes from application to application to application, straight through all the way to the end, so we can reduce distortion in the supply chain. And communicating objects, we gain real-time data about the physical world. We might include objects about weather, we might include objects about traffic, we might include objects about different products and a customer, and pull them all together and say, all of these things are important for some part of our enterprise. So the enterprise nervous system is a kind of network that connects people, applications, and devices. They may be message-based, event-driven. We do a publish and subscribe. This is kind of from the messaging systems that we talked about 2 modules ago, and generally they have common data formats. Straight through processing is real-time information. We have 0 latency. We have quick reaction to new information. As soon as my inventory level drops to 0, an immediate order is placed through. That order is received and it's actually processed so that the order is basically on its way in the next shipment. It means that transaction data are entered just once in a process, especially through a supply chain, that we're not entering it in multiple times. The goal is to reduce the bullwhip effect from processes, lags, and latency. For those of you who aren't familiar with the bullwhip effect, if you've played the beer game, which was a game I believe is either out of MIT or Harvard, which I believe in one of the classes you would actually do at Hofstra, because I did it when I did my MBA at Hofstra. The bullwhip effect is where individuals overcompensate, and so when they overcompensate certain things, they end up with excess inventory because they can't predict too far in the future. Toyota has an example of this with their just-in-time inventory, where they've been able to reduce the bullwhip effect. Real-time CRM allows a real-time response that might occur between a company and potential customer. We basically have the customer who has a question. We want that information answered immediately, either by a person or automated. Customer call or website. Websites were the best implementation for this because customers could search and get their own information without having to bother a customer service agent, and they were generally happier because they got the information they needed and didn't have to spend too much time looking for it. So the real-time interaction, a potential guest visits the website of a hotel chain, and the real-time system initiates a request to create the profile of the customer. It looks at past interactions with the customer, past billing information, past purchasing history, and in some cases what it might do is it might say, you have 1,000 reward points, I can give you this for free. And that is a good type of a customer relationship system and can make these offers. It's also a great opportunity for cross-sell opportunities where they can upgrade them. Hey, for only $10 more, you can get a suite as opposed to a different room. Or you can push them to another hotel by offering them a different rate to increase the occupancy at the other hotel. Here's an example of real-time interaction on a website. You have this slide. I'll let you take a look at it. I've kind of discussed the touch points on it already. Communicating objects are smart sensors and tags that provide information about the physical world. Now again, we talked about weather as being an option, traffic, and so forth, and I might use devices to actually get this. So not only can I get information from third-party sources that come in, but I can also use additional devices. I can use GPS items on trucks that will tell me what's on the truck, and I'll know where those products are. RFID I might be able to use within an inventory center so I can track pallets of product. Tags, RFID tags can be passive or active. Passives are read-only, and basically the way passive works is they have no data, they have no energy source, and so what happens is when the radio signal comes from the transmitter to say, you know, what are you? The passive tag actually uses that radio signal as it has a little bit of power in it, and then reflects back using that little power from that radio signal back to the transmitter, say here's where I am and here's what's on me, and you can change the element of the passive tag by programming it. Active actually has an energy source which will actually transmit the various signal. It carries far more information than simple barcodes, and barcodes, as you may know, have evolved over time from the simple straight bar to even three-dimensional barcodes. And with the advent of the camera phones, people can actually scan things immediately, find the product price somewhere else to do comparative shopping. So these types of communicating objects have also transformed both retail as well as every element within the supply chain. Real-time electronic road pricing system in Singapore to control congestion. Cards have smart card devices attached to their windscreens. They are debited wirelessly when cars pass through gantries in certain areas of the city. Variable pricing depending on when and where you drive. So think about driving in New York City, where they would charge you for just driving in New York City using your Easy Pass. You would get charged more for driving during the day as opposed to at night, and that would affect behavior. We see the communicating objects in our Easy Pass through tolls, as well as through the tolls on a straight highway as opposed to a bridge, but it'll also be used later on to really determine how fast you're going. So if I know from toll to toll that you went basically 85 miles an hour, you might not only get a toll, you might get a ticket. It would be interesting if you got a picture of your car going at a certain speed to send them a picture of a check and see if that would actually suffice as well. I'm not sure that would actually hold.